Good morning. Good morning. My name is Natalia,
And I'm Kate.
and we made an animation video to explain the geology of SF. So enjoy.
Around 250 million years ago, there was only one supercontinent, and it was called Pangaea. It started breaking up around 200 million years ago due to rifting. The idea of Pangaea was first pursued in 1912 by Alfred Wegener. His evidence of Pangaea was that the same rocks and organisms were found in different parts of the world, when there would be no way for them to get there if all the continents weren't separated millions of years ago. In 250 million years, the continents will return to being one big supercontinent. It is thought to look something like this.
Pangaea is made up of many continental and oceanic plates. Example of continental plates include the African plate, Australian plate, and North American plate. Examples of oceanic plates include the Nazca and Pacific plate. SF is currently made up of the Pacific plate and the North American plate. The Pacific plate moves about 7 to 11 centimeters northwest each year, and the North American plate moves about 2.3 centimeters southwest each year. There are three types of ways these plate boundaries can move. The first way is divergent. When plates diverge, it means that these plates are moving away from each other.
The second one is convergent. Convergent is when plates move towards each other. Another word for convergent is subduction. About 160 million years ago, the Farallon plate converged with the North American plate. After the Farallon plate finished subducting under the North American plate, about 100 million years ago, the Pacific plate got next to the North American plate. The last form of plate boundaries are transform boundaries. Transform is when the plates rub against each other in opposite directions. About 30 million years ago, the North American plate and the Pacific plate rubbed against each other, also known as a transform fault, sliding past each other in a transform fault, creating the San Andreas fault.
Now you might be wondering why these plates move. This is because of convection currents within the mantle that push the magma up the mid-ocean ridges. The mid-ocean ridge marks the edge of the tectonic plates. The mid-ocean ridge is a chain of underwater basalt mountains spanning 45,000 miles long and 100 to 1,000 miles wide. 30 million years ago, the Farallon plate stopped subducting under the North American plate and formed a transform fault. It stopped subducting because the mid-ocean ridge was too big to subduct. Before it stopped subducting, there were islands on the Farallon plate, and when it subducted under the North American plate, sediments from both plates and the island mixed together to form terranes.
The San Andreas Fault is a transform fault that goes from the northern part of the Gulf of California through western California. The San Andreas Fault forms the plate boundary of the North American and Pacific plate. The fault has moved around 400 miles over 30 million years. In approximately 15 million years, LA will be parallel to San Francisco because it is on a transform fault.
50,000 years ago, the most recent ice age started, and 8,000 years ago, ice from the ice age started melting. This water filled up where the San Francisco Bay is today.
There are lots of different types of rocks in San Francisco, but the main ones are chert, basalt, and serpentine. Let's go over the basics. There are three types of rocks: sedimentary, metamorphic, and igneous. Sedimentary rocks can either be clastic or non-clastic. Clastic means that it's from rock and mineral fragments, and non-clastic means that it's from an organic or evaporated source. Sedimentary rocks have different colored layers that are hard to separate and are sandy. These layers are called strata, and when on top of each other, it's called bedding. Sedimentary rocks come from lithification, which is when grains of sediments are formed into a rock. Some examples of sedimentary rocks are chert, shale, and greywacke.
The next type is metamorphic. Metamorphic rocks have been transformed chemically through heat and pressure and are either foliated or non-foliated. Foliated rocks are aligned mineral grains giving a striped appearance. Non-foliated do not have aligned crystals and indicate lower pressures. Metamorphic rocks are also have flaky layers and are formed by heat and pressure. Some examples are serpentine, marble, and schist. The final type is igneous. Igneous rocks can be mafic or felsic. Mafic is when the rock is darker and it's high in iron and nickel and it's low in silica. Felsic is lighter in color and high in calcium, sodium, potassium, and silica. They are also classified as intrusive or extrusive. Intrusive cools slowly underground, allowing the formation of big crystals. Extrusive is when it cools quickly on the surface and there is a lack of crystal growth. Igneous rocks are made from magma, and examples are granite, pumice, and basalt.
To summarize, the Farallon Plate subducted under the North American Plate, causing the Pacific Plate to be next to the North American Plate. From there, the plates rubbed against each other, also known as a transform fault, causing the San Andreas Fault, which is near where we are today.